Hello Econ students, just offering some help here on the Chapter 4 homework. Chapter 4 deals with market failure. Market failure is when the market fails to produce the optimal output, meaning what is best for society. And so different types of market failures are discussed and we are asked to recognize some of these failures graphically. So in number 1, you see that you've got this mixture, this trade-off between private goods and public goods. And point B gives you the market mix, which is what the market is producing and demanding. Point A is the optimal mix, which is what is deemed best for society. So what you see here is a market failure. At point B, if they're producing at that point, that is not optimal. Therefore, it represents a market failure of overproducing one good and underproducing another. So this one just asks you to recognize which one is being overproduced at the market mix relative to the optimal mix, and which one's being underproduced. So you should be able to see that pretty easily, and you're asked to put it in terms of the range, the letter range that you can see there. So that one should be, I hope, pretty manageable. Number 2 is a similar problem, and it's also about market failure, in this case externalities. And it asks you to recognize that there is a market mix, as indicated by the market for cigarettes, the market demand, which is this dotted line, and then the social demand, which indicates that it's the socially optimal demand, right? So if we think about the market for cigarettes, what's socially optimal is going to be a lower level of demand, as deemed by the government when it intervenes because it sees this market failure of these externalities that come from smoking. So in this case, you're asked to use the tools to understand the corresponding points on the production possibilities curve. And your tools are over here, and I don't think it's going to let me do it because I'm in a practice mode here. But the idea is that you're going to identify whether, each point represents an optimal mix or a market mix. So you should be able to see that you've got the lower production of cigarettes relative to other goods is the socially optimal. So, right, if you measure this, and I think you can't see it right here, but what's socially optimal is less production of cigarettes. So this point here is going to be socially optimal because it involves less production of cigarettes than this point. So I'm sorry I can't draw on that for you, but hopefully you get the idea. Whereas the production of other goods, the socially optimal point, since this is the market point, the socially optimal point is going to be up here where you have the greater production of other goods relative to cigarettes. So again, it's just asking you to recognize optimal versus market. And that has to do with this market failure. So hopefully you saw that. Question 3 is similar to that. It works on an algorithm, so sometimes you'll get a variety of questions, sometimes you'll get very similar questions, but in this case, this one looks a bit like the other one. This asks you to recognize market demand versus what is socially optimal. So this one asks you to click and drag the market demand curve to the socially optimal point to show the social demand and where it should be. So in terms of the market for cigarettes, the socially optimal demand is going to be lower, and in the problem they give you the externality cost of $3 per unit. So it's going to shift to the left by $3 per unit. And if you're not sure what that looks like, we're talking about a vertical wedge of $3. So on your graph, you can place that new curve of vertical distance of $3, so you can start it here at 12 relative to the 15. So you shift it over, and then you're asked to evaluate the results of that. All right, so let's go on. The next one gives you a similar situation. This is flu shots. So what should be clear is that since flu shots create a positive externality, the optimal, socially optimal curve is going to be to the right of the market demand curve, because that creates that positive externality, and if we're producing the socially optimal quantity, it's going to be greater at every price in the marketplace. This one is a little bit tricky. It looks like a straightforward calculation until you realize that the question says if the average adult produces $25,000 of output per year, then how much a global output. And at first you might say, oh, it's 600,000 people. But they're asking specifically about adults. So you need to read through the problem and recognize that 165,000 of the deaths are children. And so you're going to need to recalculate the information based on that. And then so you'll just total up the 379,000 deaths from heart disease, 165,000 deaths from lower respiratory, 36,900 deaths from asthma, 21,400 deaths from lung cancer, and then subtract the 165,000 deaths that are accrued to children, and then you'll multiply that value by 25,000. So watch out on that one. The next one, this one's really the exact same problem as the last one, except that you're going to take that resulting number of adults and multiply it by 26,000, or whatever number you get in the version of this problem you get. So again, just watch out for the fact that they're asking about adults. This next one is asking you about a 9% sales tax levied on consumption, and then asking you to compare the tax paid to the income earned. So you're going to do this in 2 steps. Let me walk you through the first part of this, and then I'll let you see how that looks. So in this first one, they're saying we're assuming that there's a 9% sales tax, and so we're going to apply that 9% to the consumption of $11,000. So when we do simple math, we take 11,000 times 0.09. That's going to be $990. Let's see if I can write it in there without having too much go wrong. 990. So we've got $990 in taxes being paid. And the next part of this is what percentage of income does that represent? So the income is $10,000. So we're going to set it up as a proportion. We're going to go 990 divided by 10,000. When we're setting up a proportion or a ratio, we put the total population on the bottom, the portion of it on top, and then it becomes pretty easy math here. So as a proportion of income, that $990 represents, do the math here, 9.9%. It's 0.099, but we move that decimal over. So 9.9%. And you'll do that calculation progressively throughout this, and what you're going to see is that a sales tax is generally a regressive tax in this case, because as income goes up, the proportion of income consumed by that 9% sales tax goes down. So we call that a regressive tax. Now, I don't know if the one you see is going to look like this, but there you go. And let's see, we can go to the next one. All right. The next one is the exact same setup. Again, you're going to have maybe different versions of this, but the same setup with a 2% sales tax. So it's good practice, and hopefully you find it pretty manageable. Once you have this set up, you should be in good shape. 9 is about opportunity cost of building homes, and we assume that each home's opportunity cost is $150,000, or excuse me, construction cost is $150,000. And so if we have a defense budget of $600 billion, how many houses are we giving up? And so this is actually pretty simple division. We're going to take that $600 billion, divide it by 150,000. So once you get that, you should get a really simple answer. So just division. We're taking our total budget of $600 billion divided by the cost of a single house, and that's going to tell us how many houses are given up. Number 10, the same exact process with some different numbers, but you get the idea. You're going to take your total budget, divide it by the per unit cost, and that's going to give you the number of houses that are given up. Number 11 is asking you to read an enrollment demand curve. So this one's pretty basic. If tuition is set at $15,000, you're going to see that you've got, I don't think you can see that, but you can see that 6 million students will enroll at $15,000. And then they ask you about some externalities. Suppose that society gets an external benefit of $5,000 for every student enrolled. And on the graph, you're going to draw the new social and market demand curves, right? So the market demand curve is going to be set up by this schedule, this demand schedule here. And then the social demand curve is actually going to be to the right by $5,000. Remember, we put that vertical wedge in there, so watch out for that. And here's the tuition measured on this vertical axis. So we're going to put in that new demand curve, which is going to be to the right because society is getting a benefit of $5,000 for every student enrolled. And once you draw that, you'll see the two curves, one here, and I'm estimating where those are going to go. But you can plot them, and you should be able to see pretty easily how that looks. This one, I believe, is the same idea, but in this case, it's the market for cigarettes, and this has a negative externality. And so you're going to draw the social demand curve, and then, or excuse me, the market demand curve, and then the social demand curve is going to be to the left. And it's going to be the left by the amount of $2 per unit. So we're going to have a $2 vertical wedge on our graph. So hopefully you can work through that with the tools they give you. Number 13 is about how much each family is paying. From the information in the story above, they want you to recognize what percentage of income is spent on lottery tickets in these different income groups. And they say in the story, households with less than $2,500 of income spend $1,100 a year on lottery tickets. So the setup here is pretty basic. We're going to say for this this low-income family, they're in that under $25,000 income bracket. So let's say they're spending $1,100 a year, which is the average number given to us. And we want to know what percentage of their income that represents. So again, we set up that ratio. We put the total income on the bottom, the proportion on top, the 1,100, and we can find what percentage of their income on average goes to lottery tickets. B is the same thing. We're going to take households with more than $50,000 of income buy only $300 of lottery tickets. So we're going to take 300 divided by that total income of $55,000. And to convert it to a percentage, by the way, you're going to multiply it by 100. And by that I mean move the decimal over 2 places to the right. So you can get those numbers pretty easily, I believe. All right, let's go to the next one. 14 and I believe 15 are, well, I don't know this, but I think they're the same in the sense that it's asking you to evaluate the trade-offs in this graph between all other goods and housing units per year. And they ask you about the mixtures at point A. And you can see at point A, it's the emphasis is on very little housing, but a lot of the other goods. And is it, they tell you that the current mix is at point A and the optimal mix is point D. So right off the bat, you have a few questions you can answer from that. So A, does a market failure exist? Well, if it's anything other than optimal, yes. And then it says, if the government has a laissez-faire approach, and hopefully you remember that expression, laissez-faire means the government stays out of it, hands off. So will it intervene? No. If the government intervenes and the economy moves to point C, which is the optimal point, well, it's closer to the optimal point, I should say, is it a government failure? Well, no. It's not necessarily to optimal, but it doesn't represent a government failure. It doesn't make things worse. And then finally, if a politician has self-interest to keep the current mix of output, despite the desperate need for more housing in her district, based on your knowledge of public choice theory, will the politician intervene? And public choice theory deals with the personal interests of the people making the decisions, the politicians. So in this case, it would be a no. So let's take a look at that last one. I think it's similar, but I could be wrong. No, it's the same sort of question. But watch out because it looks exactly the same. The graph is the same, but the questions are going to be different. So it's going to ask you, in some ways, the same questions, but maybe worded differently or looking for different information. So you should be in pretty good shape with this. And I hope you'll work through all 3 options. I would take all 3 alternatives and take them. Remember, you're given the highest score of the 3, so there's no risk in trying it again and again. Seeing it lots of different ways will better prepare you for tests. All right? So best of luck. Bye for now.